Okay, today first we talk about the process of nuclear fission and nuclear fusion reaction. So first, if we talk about nuclear fission reaction, and you also already know about the basic structure or the model of an atom. So according to Rutherford, the central part of an atom is known as nucleus, right? Where we have
Yes.
total protons and neutrons are combined together in the nucleus, and electrons are just orbiting around the nucleus, and most of the part of the atom is empty, and 99% we say that mass of an atom concentrated in the center of an atom, right? So basically nuclear fission reaction is related to when we try to break the atom or when we try to break the nucleus of an atom. So we know that the center of the atom is nucleus, and protons and neutrons are strongly combined with each other, and that is known as the binding energy to overcome or to break down the nucleus of an atom. So in this process, nuclear fission reaction is same like the process of the atom bomb, because atom bomb is the application of nuclear fission. And in nuclear fission, let's suppose if we take uranium element. Okay, so we have uranium, and we already know about the radioactive elements, that these elements are unstable, right? So all are unstable. And if we start bombarding the neutrons on this uranium, so multiple neutrons are bombarded on the uranium. And let's suppose if one of the neutron hits the nucleus or hits the central part of the atom, so this uranium will become more unstable, right? And if it absorbs neutron, or if neutrons include in the nucleus of this uranium atom, so it will become more unstable, and it will start emitting, or the nucleus of this uranium will break into small nuclides, right? This is the massive nucleus, and it will break into small nuclides, and those small nuclides are barium and krypton, right? So the simple process is, if we start bombarding the neutron on uranium, so it will split or it will break into two small nuclides of barium and krypton, plus it will also emit the neutrons. So it will also start emitting neutrons, and this chain reaction will continue, right? So this is the whole process of nuclear fission. And if you want to write in words, so in words we can write it as nuclear fission is the process of splitting up the nucleus of an atom into small nuclei. So this is the simple statement of nuclear fission reaction, that in fission reaction we split up a large nucleus or a single nucleus into a small nuclei or into two small nuclei, and already we have reaction over here that we just bombard neutron to uranium, and that uranium splits up into two small nuclei, that is barium and krypton. And this uranium, if we talk about the uranium 92 235, so this element is known as parent nucleus, or we can say that parent nuclei. And the other elements which in which uranium will split, that is barium and krypton. These elements are known as daughter nuclei, right?
Yes.
Okay. So if they ask about, or if they ask with the reference of the term, so parent nuclei means the element which we are going to break into small nuclei, and those small nuclei are known as the daughter nuclei, right? Okay. Further, if we talk about the nuclear fission, so in nuclear fission, you observe from this diagram that this is complete a chain type reaction. So this reaction is known as chain reaction. It will continue splitting into small nuclei, and it will continue unless it will completely break down, right? So this is chain reaction, and this chain reaction is same, or you can say that the atom bomb is the application of this nuclear fission, because atom bomb means that we have to break that atom, and after the breaking of that atom, and you just imagine that how strong or how much energy is stored in the in a single atom, that if we break that atom or if we split that atom or the nucleus of that atom, so it will radiate a huge amount of energy, even it will destroy the whole city or the whole town. So how much energy is stored in a single atom, right? So that is the power of single atom, that it is bind with such huge amount of energy, right? And you also saw the documentary of that Hiroshima and Nagasaki that was made on the nuclear attack of that atom bomb. So that is the practical or the real life example of the nuclear fission reaction, that for how many and how long years the radiations or the after effect of that nuclear fission will be there in their atmosphere, right?
Yes.
So the most important factor is that we are getting that small nuclei, plus we are also getting energy, or we can say that thermal energy. Okay, so this is the process of nuclear fission reaction. And if we talk about nuclear fusion reaction, another process which is named as nuclear fusion reaction. Okay, so now fusion reaction is just opposite to the fission reaction. In fusion reaction, we are going to combine small nuclides to make a heavier nucleus, right? So if two or more than two small or lighter nuclei, join together to make heavier ones. So this is the statement of nuclear fusion, and nuclear fusion is the opposite, or you may say that it is the opposite process of the nuclear fission reaction, right?
Yes.
And if we take the common example of nuclear fusion reaction, so fusion reaction occurs at sun, and it may also occur in hydrogen bomb. So if we talk about the sun, because sun is the common example, and we observe sun every day, not from very close, but we still know enough knowledge, and if we still have enough knowledge about the sun, that sun is a ball of fire, we say that, and there are multiple experiment process or explosions take place on sun every time, because there are multiple gases over there and a huge amount of thermal energy over there. So, and you may also take idea from the amount of energy from the sun, that sun is far away from us, and still we feel the hotness of that sun. So it means that how much thermal energy is going to be released by the sun or by the nuclear fusion reaction. So same energy will be emit out by the nuclear fission reaction. So with the help of sun, you may just take idea of the amount of energy, that how much energy we are going to emit out from the nuclear fission or nuclear fusion reaction, right? And if we talk about the temperature, so temperature was about, if we talk about the estimated value, so over 100 million degrees Celsius is the temperature. So that is very much huge, and that is the amount of heat which is going to be emit out by the sun or by the nuclear fission or fusion reaction. So it means that the collision of particles, because if we are working with high temperature, so we already know that kinetic energy is directly proportional to temperature, right? So collisions occurs at high speed. So this is the process that we need to know about the nuclear fission and nuclear fusion reaction. And I think it is very simple to understand that what is the difference between nuclear fission and fusion. Only similarity between nuclear fission and fusion is that we are getting huge amount of thermal energy in both process, right? Any confusion?
And now it's clear.
Okay. So another topic of this chapter is related to nuclear reactor, and this is the final topic of this chapter. After that, we will continue with questions, and then we will start the section of thermal physics, right?
Yes.
Okay, if we continue with this topic, so let's suppose we have, first we have to select a concrete shield, right? Because we know that these are radioactive materials or radioactive elements. So it means we have to first take the safety precautions, then we will continue with the reactions, right? So initially we have a concrete block. Okay, this symbol is much similar like the National Geographic symbol, right? The yellow
Yes.
frame. Okay, so further in this nuclear reactor, we have, okay, this is the internal structure, and these in this whole process or this whole control system, we are going to place uranium rod and control rod and graphite rod. So multiple rods are going to be add over here. So that's why we kept this whole process in a concrete block. And this is the passage for the pump over here. And we are getting a pump over here. Okay. And further on the upper side, if we continue with the upper side, so we are getting a multiple rods over here. Okay, so we are having a colorful nuclear reactor over here, and only few things are left in this reactor. Okay, let's start labeling them so that will help us to identify that what we are going to. So this is a concrete shield. So yellow box is basically a concrete shield, and further we are going to connect a control rods over here. And before that, let's take some different material again over here. Okay, so these are basically graphite core, and these are graphite core. And now we have to select a push rod over here. Okay, so these are control rods. Okay, so these purple rods are basically control rods. And further, if we talk about the remaining parts, so one more thing we have over here. Actually, that green color rods are behind these control rods. So those green rods are known as uranium rods. right? So this is the setup till now we talk about, and now let's continue this setup and draw out the remaining part. Okay, so this is the process, and this whole process is moving towards the pump. And on the upper side, we also have opening over there. Okay, now here we have a cold water and a hot water container or a stream type material. And this is connected with the pump. Okay, so this part is known as the pump over here. And from here we are getting the cold gas. And we have some empty block over here, and that empty block means, and this part basically shows you the stream of water. And this whole container is known as heat exchanger, because too much heat is going to be produced from the whole setup on the left hand side. And this outlet is for the cold water. And here we are getting a hot gas over here. Now you may somehow know, or you may somehow guess the function of nuclear reactor. That whole nuclear reactor or whole nuclear particles and all the safety material are placed over here in this container on left hand side, and from the upper side we are getting the hot gas over here, right? And that hot gas passes through the steam, and we are passing the cold water from it. Cold water passes through it and it comes out from this part. That is the part of a stream over here. And this whole container is known as heat exchanger or heat changer. So it means it will change the amount of heat, and cold water is coming from the downward pole. So it means after gas pass through this whole heat exchanger, so we are receiving cold gas from this lower part, right?
Yes.
So this is the general idea of nuclear reactor, that how this nuclear reactor is going to be worked over here, right? And if we talk about the whole process, so the basically heat from a nuclear reactor produces the steam for the turbine, right? That you may see over here, that this whole nuclear reactor produces the steam in the turbine, because we also discussed this topic in the chapter of work energy power. And we also discussed that nuclear reactors are also a source of producing electrical energy with the help of nuclear thermal energy, right? And we are having,
Yes.
yes, and we are having uranium over here. Uranium rods are over here. So it means chain reaction is going to be take place over here. So again, we have a chain reaction over here. Okay, so chain reaction is going to be take place over here, which is controlled by the absorbing rods, right? Or you may say that the control rods. So chain reactions are going to be controlled by these control rods, right? Because once chain reaction start, we have to control that chain reaction, otherwise it will continue expanding in all direction. So that's why we use control rods, right? Which are made up of usually from boron. So these control rods are made up of boron among the uranium rods, which are placed behind or from the green color which are mentioned. Okay, and why we are using these graphite cores? These graphite cores are like moderator, right? So the purpose of graphite rod is like a moderator to slow down the fission neutron. Okay,
Yes.
and uranium rod are used for the nuclear reaction, and we know that concrete shield is very much important. So nuclear radiation will not emit out or will not flow outside very freely. And control rods are made up of boron to control the chain reaction. And on right hand side, we have a heat exchanger. So in the heat exchanger, the heated gas transfer energy to the pipes, right? If you consider the path of this pipe and this is passing through the pump and to the cold gas. So the purpose of the heat exchanger is to cool down the steam or cool down the gas or the hot gas which is coming from the nuclear reactor and convert into the cold gas and transfer again to the nuclear reactor, right?
Yes.
So this is the whole process, and this whole process may also be used in atom bombs to control the chain reaction. So by using that process, we may also control the nuclear reaction or the nuclear fusion and nuclear fission reaction, because huge amount of energy is going to be emitted by both reactions. So we have to control that reaction if we are going to use that reaction for our purpose, just like to generate electricity or just like to use in some other application, right? So that is the purpose of nuclear reactor. Any confusion?
No, it's clear.
Reaction is very much simple. Whole setup is made up on left hand side for nuclear reaction, and right hand side is made just to control or just to control the reaction and start the reaction again, right? So that is the process. Okay, so now we let's try to solve some detailed question of this chapter, because now we have two more topics of nuclear fission and fission. So let's continue to solve the detailed question. Okay.
Yes.
Okay.